Okie dokie. It's 2:50, so we're gonna start now. I wanted to start off today with a little bit of announcements, and then what we're gonna do today, and then we'll get into that. So we should be wrapping up sections 1.3 and 1.4 today, and if not, Thursday. So I scheduled your first exam to be next Thursday. Next is spelled with a T. Can everyone online hear me? Okay, thank you guys. Great. So next Thursday, which is September 24th, I'll update the syllabus agenda. The sections are all the same. So every section that we've done so far, including 1.3 and 1.4 that we're going to do today. And if we don't finish today, we'll wrap up on Thursday. So you'll have like a week from when we end material to when our exam is. So this is how it's going to work. It's kind of work similar to how your homeworks go each week, right? You take half of your homework on WebAssign and you do the other half of your homework written and you turn it in to me. You should be doing that. There are still people that have never turned in a written assignment. Those are sad homework points you're not getting. But so it's going to work the same. So your WebAssign problems are going to look pretty similar to your homework problems. It'll be timed. So I think, I'll have it opened, like available during class time on Thursday. So you guys aren't going to be coming in on next Thursday for class. Oh, it's going to keep rolling. Did it stop? Okay, cool. So it'll open at like 2:50 next Thursday on WebAssign, and you're given a 30-minute time from when you open it to take that. Oh, you guys always have questions. Yes.
It's not like you have a limited time.
No, yeah, this is an exam. This is not a homework. Yeah, this is something that like an assessment. Yes, Mathis.
The WebAssign is going to tell you like when you get it right or wrong. Right.
You guys are gonna have. We haven't got to that part. You're gonna have a practice exam. So to get used to it, you don't have to do it, but I would recommend it just so you get used to the software of how it's different from a homework versus when you take your exam. Yeah. Oh, yeah.
Sorry.
Oh.
And then you said it's going to be like open to start the exam on Thursday during this whole like class time, so you can start it anywhere between like 2:50 and.
That's the plan right now. I might open it for the day. So if you have like a break in the day, because the half that you turn to me on Blackboard, it's gonna be just like a typed up how if we were in class and I would hand you an exam, it'll look like that. So you can either print it out, do all the problems, and that will be open for the whole 24 hours. So at like 12:01, what was your question, Mathis? Oh, will the online exam be open the whole class? Yeah, I'll make it the whole day. That makes more sense. So yeah, they'll both be open and available at like 12:01 Thursday morning a.m. and then you have to turn in everything and be done by everything by 11:59 p.m. That's a hard stance at 11:59 p.m. if it's you like really got to turn that into me. This is an exam. This is not a homework that you're like, whoopsies, forgot about. Tee. No. Like this is when your exam is. You know this is when your exam is. Ta-da. Okay? Right, like I said, so you have all day to do your written portion of your exam. I can't like time you on that. I don't really know how to do that. So you must turn in a scanned copy to me by 11:59 p.m. Make sure you're uploading the right thing. I had a lot of people uploading me a movie file, uploading me a page from their homework of last week on recent homeworks. I really need you guys, when you're submitting your exam, to review the documents before you hit submit and make sure everything is there. It's not turned upside down, it's not sideways, it's legible, so that I can like grade it right, okay? I want you guys to take this like very serious. So I'll post a practice exam soon. I haven't written it yet, but it'll be a practice exam version of both, right? So like practice exam on WebAssign, and yes, Dahlia, and a practice exam on Blackboard. I also posted the solutions to the Blackboard one as well. So Delilah asked the app that I use to scan. I use this to scan my homework for my classes. It's called Adobe Scan. Scanning app. Here, write this down. I think sometimes when you upload a picture that has been like a live photo on the iPhone, it sometimes uploads it as a movie. It's literally just called Adobe Scan. It's really great. It takes a picture of it and uploads the white balance. Yeah. Okay, cool. I don't have an Apple phone, so I don't know these things, but that's really cool. So it's Apple Notes. We'll do it. I'm gonna write that down. I'm not familiar with that, so I cannot fully endorse it. Adobe Scan I love. It's really easy. Just has a little picture. You say document, and then whenever you like hold it over your document, you're gonna do it. Beautiful. And it like scans it and makes it nice and pretty so you can like look at it later. Okay. Ooh, there will be a review session on the Wednesday, so the day directly before your exam. I don't know what time. We're gonna talk about that in a hot second. So bring questions. I'm not gonna bring material to review. I wanna know what you guys want to know. So bring questions. I can answer questions about the practice exam. I will not be recording this lecture. Is that your question? Yeah. Okay. Yeah, I'm not recording it because your exam is take home. So a practice exam is supposed to be practice for the exam. There's like academic integrity that right there that I don't really want to mess with. So I wanted to ask you guys what time would be best on Wednesday. I have class until 5 p.m., 5:10. So what time is evening the best for you all? Is like 9 a.m. best for you guys? Please say no. Thank you. Okay, great. So people online can also throw in the chat or turn on your mics, but I just kind of want to know what time, in the evening would you guys like? Okay, 6:45. Oh my God. Actually, yeah, I'll be done with dinner by then. I also cook dinner, so like I have to factor that in. It's 8 p.m. It's going to be on Zoom. Yeah, right. So it won't be here. I don't know where to reserve a room. I literally do not know how to do that. And I have to do it like weeks ahead of time. It's silly. Yeah. Probably like an hour, right? You guys need to get your beauty sleep before your exam. No, ends at 8. Yeah. It's next Wednesday. Thank you, Delilah. Yeah, 9:23. Okay. Yeah. You just like come whenever you want. That's a review session. It's not like a class I'm holding. Like, it's come when you need it. If you feel like you're there and you're like, I'm not really, you can just be like, peace out and leave. No offense there. So, okay. 8 p.m. on Zoom. Is everyone okay with that? Most people are okay with that? Okay, great. Let me put this in my phone so you guys aren't like just sitting in there and you're like, where's the review section? And I'm just like chilling on my couch. Doo-doo-doo. Event. Review session. So yeah, come with questions. I will come with answers. Okay, save. Great. Oh, cool. So for the agenda for today, we're going to do a little homework review about the homework that you guys just turned in to me on Thursday. And then we're going to go through section 1.3 and then section 1.4. All right. That's all we have today. So I wanted to talk about one of the questions that I got a lot of comments, questions, and concerns about on the homework. So C.1.68. Also, really quick thing about homework. Make sure you guys are doing the right problems. I tell you what section it is, and a few times now you guys have been doing questions from a different section. Just really be careful about that. I've been generous in letting you guys redo the problems, but just like really be careful. Mathis.
If, like if we had to redo a problem or whatever, where would you like leave a comment or like tell us?
Oh, that's a good question. Okay.
Like, how do I see?
Okay. On Blackboard, I can't show you because that'll be against FERPA to show anyone's. I think if you click on assignments and you go look at the grade that I give you and click that, you can pop into it. And I make comments on all of your homeworks of like, hey, no, hey, great job. This is awesome. Hey, kind of almost there. And like comments on like most of your problems on every homework. I spent a lot of time doing that for your benefit so that you guys can, because I can't like annotate a homework and then like that's my way of handing it back to you. So if you go in assignments where you've submitted it, and I'm pretty sure you click on it, it will tell you like all the comments I've given you on your homework. Also, solutions for the homeworks have been posted too for 1 and 2. Obviously not for 3, you haven't turned that in yet. Okay. Just be really careful about the problem, like double check that you're doing the right problems, right? Okay, cool. So solve the equation. Okay, yeah. So C point 1.68, you were asked to solve the equation for the indicated variable. So specifically, we were given that 2.1a equals 2.4 s to the 1.8. And we were asked to solve the equation for s. Okay? So solution. I'm going to rewrite our equation. Who wants to tell me what they would do first with this problem? There's no one right answer of what we should do first, but what can we do first? Yes. Yeah, I would do that as well. So we're going to divide. Why do we do that? Yeah, we want to get S all alone. We're isolating the variable. So can someone tell me what 2.1 divided by 2.4 reduces to? There's another way we could have written this. Yeah, it reduces to 7/8. So really quickly, 2.1 over 2.4. You can write this as 21 over 10 and 24 over 10. Just going to be 21 over 10 times 10 over 24, blah, blah, blah. These guys cancel out, or because they simplify to 1. And this is reduces to 7/8. So what I would have done is made everything, every decimal into a fraction, and then simplified. So if I make 2.1 and 2.4 into fractions first, it might help me out down the road in simplifying 2.1 and 2.4. That does reduce to 7/8. Okay. Any questions about 7/8? Okay, cool. What should we do next? I saw a lot of different answers at this part. Right, so I can also make 1 over 8, like, yeah, no. So like 18 over 10, which is just 9/5, right? So I can rewrite this as s to the 9/5. So to get, when I'm asking to solve for s, this is like s to the first power, right? So s isn't to the first power right now, it's to the 9/5. So to make s be to the first power, I raise everything to the reciprocal of 9/5, which is 5/9. What I do to one side, I have to do to both sides. 5 divided by 9. So that leaves me with 7a over 8 to the 5/9 equal to s. You can also write s to the first power, but that's kind of redundant. So is 7a over 8 to the 5/9 correct? Yes or no? I'll let you think about it. Why not? Isn't it not multiplied by 7/8 here? You're correct that this answer is, what did you say the answer was not correct? Yeah, that's correct. Do you know why it's not correct?
Yeah, because the 5/9 would only go to the A and the 7 would not.
It only goes to the A,
Okay.
right? So right here, when you write it like this, first of all, I can't really tell what it's going towards, and kind of like an exponent floating away. But if you just tell me like 5/9 like this is like the 5/9 is only onto the A. So I just have like 7 still to the first power and 8 to the first power, which is not the same as this answer, okay? I also saw a lot of interesting answers. And I kind of wanted to address it. I didn't take points off of it. I saw when you meant to take the reciprocal of 1.8, I saw a lot of like something like this, where above the radical you wrote 1.8. I did a little researching, talked to some mathematicians because I had never seen this and I wanted to make sure I was going to tell you guys the right thing. Oh yeah. Doop. So, is correct. Technically, this is not correct. Having a number above this radical, that's not a whole number, that like doesn't exist. The notation, it's kind of, it just doesn't make sense, if that makes sense. Why am I putting 1.8 over 10? Oh, that's a cool question. Why am I putting 1.8 over 10? I didn't. I put 18 over 10 so that we could make it into a fraction, because we only really know how to deal with exponents when they're fractions and not when they're decimals. So that's why I rewrote 1.8 as 18 over 10, because that's how we can write decimals like that. Does that answer your question? Okay. So we don't really write a root right here, right? We know that we can write cube root of something, I guess y is 1 over 3. Or if it's just nothing, there's a 2. But it's kind of improper to write a rational. I know your intentions were there. I just really want to refine your mathematical notation in your mind. So looking at this, you'd be like, oh, well, if I just did something like that, it should equal this, but not really. It doesn't, this only works with whole numbers. The way that we can rewrite this, so if I have, if I wanted to write 7a to the 8th, everything to the 5/9, how can I write that with a radical? There's a way I can do it. How can I rewrite a rational with a radical? Yeah.
Power over root of the exponent. So it's like 7a to the 8 to the 5th power, and then 9 to the
Yeah, so, whoopsies. So we have 7a to the 8th, all of that to the 5th power, and then I can have a radical with just a 9, right? Because I'm basically, the middleman right here is saying and this whole thing is to the 1/9, right? Because we know that exponent rule where I can, what is this? Nothing. Okay, sorry. I thought I had a pointer. This is my pointer. Exponent rule says if I have an exponent, parentheses, another exponent, they multiply. And I can work that backwards, so then I can write a radical. Does that make more sense? So if I see a decimal like this and a radical, I'm going to take points off for it. So I now know that it's wrong. You guys didn't know that, so I didn't really know that. So I just wanted to clear that up. All right, so this doesn't really exist. Something like this is kind of what you were intending to write. So if we see decimals on a problem like this, your best bet is to write your decimals as fractions. They're not going to be like crazy decimals, like you wouldn't know how to write as a fraction. All right, so the right answer is 7a divided by 8, all raised to the 5/9, right? Okay, cool. Any more questions on this problem? Are you guys feeling a little bit better about these types of problems? Okay, can you guys hear me online? Because I've addressed both of these problems. Oh no, that's that computer. I have like 3 screens going on right now. Okay, great, cool. So this is the final answer. The reason that we write a decimal, this is just 1.8, this is 18 over 10, which is the same as 1.8. Does everyone understand how I made decimals like this? Right, I have an 1/8 in the 10th place. Okay, cool. Alrighty, moving on. Anyone have any other questions from the homework? If not, I still have office hours at the same time on Monday and Wednesday. And you can always schedule another time. Okay, cool. Now we're going to skedoodle over here. Cool. So now we're moving on to chapter 1. So we were in the back of the book, now we're in the front of the book. Chapter 1 is all about like data and functions and models and what I can do with numbers and like all these like fun real life examples. So far we've been doing problems that are called procedural. I give you just an equation out of no context and I say solve for X. That's kind of what we can say is a procedural problem. You're just going through the steps. A conceptual problem is what we're going to get working on now, where I'm like, oh, I'm in the real world. I have this data. I want to do this with the data. I've done this. What else can I do? So we're on section 1.3. There should be a 3. 1.3. And section 1 in there, we're going to, okay, wait. Section 1.3 is all about equations and describing relationships and data, right? So in the real world, you collect data and you want to use that data to make predictions about information you didn't collect on that data. I know that I can do, a somersault, and I know that I can do something else, a back handspring. From that, can I do something else? These are the only gymnastic terms that I know. Something like that, right? So our first example, you're going to imagine that you can scuba dive, which is super cool, right? So imagine you want to know the pressure underwater. You go scuba diving to collect data by measuring the pressure at different depths. You use this data to create a model, which is just a relationship between pressure and data. So that giving you kind of an example of like what we will be doing. So at depth 0, you're just chilling on top of the water. There's just kind of like this normal pressure of 14.7, right? I go down 10 more feet. The pressure is 19.2 pounds per square inch. And I keep going down 20 feet. The pressure is 23.7. I go down 30 and the pressure is 28.2. Well, I can't really scuba down all the way to 200 feet, but from all this data, how can I figure out what the pressure might be down there? So we take this data and we make a model with it. That model is going to look kind of like this. P is equal to 1.47 plus, here, let me get rid of this box, ugly box. (0.45 times the depth, right? So P is pressure, little d right here is our depth, right? So from this model that I have created using this data, we'll get to like how we can do that in a second. I can then use this model to predict what's happening at 200. How do I figure that out using the model? Oh, I heard some mumbles. Right, I would plug in the depth, right? So if I want to find the pressure, I want to plug in so the model is, this is just an example, right? So was that 4.6? 1 second. I need to make sure that number's right. Yeah, it's right. Okay, cool. I would just plug in 200 for my depth, right? Then I should spit out 104.7. And in real world, I need to give answers in units, so pounds per inch squared, because that's the same unit that all these guys are in, right? So that's how I can use a model from data that I've already found to then predict in the future. This model, oh my gosh, okay, I see it. See all your questions. This model is just an example, right? So there's a lot of things that goes into model making, which is kind of what my degree is. And we'll talk about how to make this model in just a second. I'm just giving you guys an example, okay? So just kind of giving you an example of how I can, if I have data, I'll eventually have a model and then I can use it to predict. So you guys are so excited about learning how to make models. We're getting there, okay? So first we need to define what it is to be a model, right? So a model is a mathematical representation of a real world situation. Usually we like models that are linear. So a linear model is in the form y equal to a plus bx, where a is my initial value and b, we add b for every change in x. So we'll go through an example in a second, but basically, if I have a linear model, ax, oh my God, a plus bx, what equation does this kind of look like that you guys have seen before? Yes. Yeah, slope-intercept form, right? It kind of looks like y equals mx plus b. What's m? If you have seen this equation before, it's your slope, right? So that's kind of what b is, rise over run. If I'm going, so kind of right here, 0.45, that's how much the pressure is increasing for each foot I go down in depth, okay? So that's kind of where we get b from. And a is your initial condition. If you want to think at your y-intercept as where you're starting, okay? So following. We're given another example on how we're going to walk through making these models. A furniture maker collects the following data, right? So we're going to call X the number of chairs and our cost these values. So if I have from 0 to 4 chairs, it's 80, 92, 104, 116, and $128, right? So you're asked to find a linear model for the cost of making X chairs. Every additional chair costs, well, let's see. If I'm going from 80 to 92, that difference is 12. That's the difference between 92 and 104. It's also 12, 12, and another 12. So the additional cost of each chair is another $12. 12 more dollars, right? So what would B equal to? 12, right? Because that's the change for each additional chair. A is the initial cost. So what's the cost of making 0 chairs? Someone mumbled it. Yeah, $80. I don't know that. So far, we're just talking about linear models, and we'll get to talk about a little bit more, but probably not. Maybe in the future, whatever your math career holds. But in this class, so far, we're just going to talk about linear models for this section. Okay? So what would our equation for cost equal? How can I write this equation now? Yes. What is y? So it's not going to, so that's not an equation. That's an expression, right? There's no equal sign. So we want to write, you're really close. It's C equal to 12x plus 80. You can also switch it, right? 80 plus 12x. Doesn't matter which way you add two numbers. But yeah, so you have to be careful. So we used x up here because that's what we were told it was x and c. So if you tell me y equals, I don't know what y is. Y is a different variable. I don't know. I don't. Who's stranger to me? No idea. I only know x and c right now. Okay. A few questions for you guys. Why isn't a equal to 0? Just kind of like in real world contents. Why wouldn't a equal to 0? I'm not making any chairs. Yes. Right? Yeah. I have to like pay rent. I have to pay electricity. I have to pay my employees there, right? So usually if we're talking about cost of something, it'd be really weird if the cost at time 0 is also 0. So watch out for that. How can I, yeah, that's exactly right. How can I check my equation? How can I check if my equation's right? Yeah. Right, I can plug in any of these x's and I want to make sure that I get one out. Right. I probably don't want to plug in 0 unless I'm really checking my initial condition, which is just 80. But if I plug it in like 3 and then I get 116 out, my equation is probably going to be right. Okay, so that's how we can check ourselves. So then we're asked to graph the model. Let me draw a little graph. Okay, great. So if I create little ticks, so this is going to be 1, 2, 3, 4. Make this like 80. Okay, cool. So I did a little scribble here to show that I was starting at 80. So if I ever ask you to graph something, how are we going to do that? Here are my points again, if you need a reminder. How would I graph this? I would just put the numbers on the graph, right? And then connect them. So at 0, let's do, what's a fun color? Purple. So if I have a purple dot here, at 1, it's what, 92? Kind of right here. Oopsies. At 2, it's 12 more, then 12 more, and then 12 more, right? Each time. And then I can connect them all. Whoop. Act like those points align. And I get a straight line. That's what I should expect from a linear model. Linear has the word line in it. So I want to I expect a line when I graph it. Yeah.
You take points off if we don't put the arrow
Oh, like right here.
on. Yeah.
Not really. I'm pretty lazy when it comes to like, I'm technically supposed to like put little arrows right here. So not really. WebAssign, I haven't looked at the problems for this chapter for WebAssign. They might be a little bit more sticklers than I am. So just watch out for that.
Oh, I've done all of them, like for the graphing and stuff.
Okay.
It just does it for you.
Okay, beautiful. That's what I assumed. Right? Okay, cool. So, not all data satisfies a linear model. We had a question about this earlier, right? What if the numbers don't work out so nicely? Then it's not a linear model, right? So we can tell if the data satisfies a linear model if there's, ooh, I'm in the wrong color, what we call a common difference. Right? So if there's a difference and any two successive points is the same, right? So if you look up here, sorry, I know I just wrote something down, I'm scrolling. I went from 80 to 92, that difference is 12. I went from 116 to 180, that difference is 12. So those points that have a common difference between them, which we just talked about is going to look kind of like our slope. Not kind of like, it is our slope. Okay? Then we can create a linear model. So when I say the important part about this that I don't want you guys to miss is the two successive data points. Well, if I'm comparing, I know I'm scrolling again, I'm so sorry. If I'm comparing 0 and 2, well, that difference from 80 to 104, excuse me, is 24. But then the difference between 3 and 4 is 12. If you tell me that's not a common difference, I'm going to be a little confused, right? So we want to look at successive points. Hopefully every time I'm giving you a point like that, it's going to be like 0, 1, 2, 3. That's not going to skip around. It shouldn't. Okay? So right, if I have that common difference, then I can create a linear model. Okay, cool. So our next example, the temperature at various elevations was recorded below by a hiker. So our elevations in kilometers, we start at 0, we go all the way up to 5 kilometers, and our temperature is in Celsius. I didn't know how to make the little degree sign. So act like there's like a little degree, okay? You're asked to show that this data satisfies a linear model. How can we do that? Oh. I'll give you a second to write and think. How can I show that this data satisfies a linear model? Yeah, I can graph it. That's a good way to do it. So I'm gonna do that to the side over here. Oops, that's not a line. right? So let's say I'm going from 1, 2, 3, 4, and 5, right? So at 0 kilometers, this is kilometers, this is Celsius. We're going to be at 20, and then at 1 we'll be at 10. What about at 0? Or 2? We'll be at 0. At 3 kilometers, we'll be at -10, -20, -30. My graph spacing isn't that perfect, right? I'm not that good at that. So let me put these dots on the line. Act like that's a straight line for my self-confidence, right? So that kind of looks like a line, right? My drawing skills aren't too great. So I'm like, oh, is that a line? Is there a slight curve to it? So that's one way. What's another way that I can make sure that it satisfies a linear model? Yeah.
Isn't it like if nothing in the temperature category repeats itself?
Not a line. You're thinking about you're giving away a little spoiler, so what we're going to talk to later today. But what you're thinking is on the right path, but not technically for a line. Yes. Yes. Right. So that's another way we can do it. Right. So we can make a table from all the data and look at my common differences. So do a little line over here. Make a line. Come on. Hold on. Okay, whatever. That's just going to be ugly. So we can look at the change in what? Elevation. Versus the temperature change, right? So between 0 and 1, what's the change in temperature? Yeah, -10. Good job. Right? I'm going from 20 to 10. I'm going down 10. And then from 1 kilometer to 2 kilometers, let me draw little arrows. I'm going from 10 degrees to 0 degrees. I want this to make a line for me. Thank you. That again is -10. If I go from 2 kilometers to 3 kilometers, again, I'm going from 0 to -10. That changes -10 as well. And so on and so forth. So now I have a common difference of -10. And what we just said, that if there's a difference, if there is a common difference, we can create a linear model so the data satisfies a linear model. It's like another way of phrasing it. All right, is everyone kind of feeling like thumbs up, thumbs sideways, thumbs down so far in linear models? Okay, beautiful. Math is, sorry.
Could we show the data like in either way, or do you, is there a preference or?
So, right, I kind of showed how when I drew a line, it like, I didn't really make them. My handwriting was a little shoddy. So the best way to guarantee that your data satisfies a linear model is to kind of make a little chart and make sure that check that there is a common difference, right? And I checked a lot of places. I kind of just went down the line and made sure that it was the same. I'm not saying the graph is wrong. It's really great, right? Always to draw a picture. That's an awesome, that's like kind of where I always start, is just draw a picture. At least at this point, you kind of know that you are on the direction to a linear model. I'm just kind of going one direction. Yes.
To prove this too, could you write almost like a proof using these successive points if you want like work? What I would have done is I would have just plugged in 6 and 7 using the first one, like, and then follow that.
So off that, you are proof by assumption, right? You assume that as a linear model, here's prediction for these kind of going forward, and they made a line. So since this is, I'd rather kind of the chart, right? I don't want to get into proof writing so far. That's a little above, I don't get paid enough for that. So we're gonna stick to, I would recommend, and kind of when I'm asking you, show that this data satisfies the linear model, I want you to show me that there's a common difference, right? So that's kind of what I'm going for. That's a good question. Okay, cool. So now I want to find the linear model between temperature and elevation. Oh, also I messed up. Common difference is 10 degrees Celsius. When given real world examples, you want to give answers in terms of units, sorry, that have units with them. So my common difference isn't just 10, it's 10 degrees Celsius. I didn't add Celsius here because I kind of already indicated that it was going to be temperature change. Okay, so I want to find the linear model between temperature and elevation. So I need, who wants to walk me through how they would do this? We know we need, our equation is going to look like what? Let's call this big T. Temperature equal to A plus B. And our height is H, right? So how can I figure out what A and B are? What does A traditionally stand for? Yes. Say it again? Yeah, how did you get 20? Right, so it's our initial value, right, and so we know that's going to be 20 degrees Celsius. So we'll just write 20 for the time being. What if I didn't give you something at 0? Would that change your initial value? No, right? Initial value, initial is kind of when we mean when this variable here is equal to 0. Okay, so that's what we mean initial. We could start at how many levels above sea level, but my initial value is still when H is 0. Okay, just wanted to clarify that. Okay, cool. So what should B equals? -10, right? It's my change in every step of X. So I'm actually not going to have a plus right here. I'm going to have a minus. Why am I still writing in blue? 10H. Okay, great. Any questions so far? Okay, great. We're gonna move on. So the point of a linear model, right, is so that I can use it to predict stuff that I can't necessarily measure, right? Like an extrapolation, if you've ever heard that term. So I've taken data, I've used my math brain, I've inserted it into a model, and now I'm going to predict things. So the example that's in this book, it talks about for a whole page about this thing called a bathysphere. It looks like a giant mechanical Mike Wazowski where you like go into the depths of the ocean. It's like really hilarious. I highly suggest reading about it. It's really funny. So a bathysphere is lowered into the bottom of a deep ocean trench. If the depth pressure model is P equal to 14.7 plus 0.47 D, kind of the model that we saw earlier, what is the pressure at 300 feet? 3,000 feet. So I've collected the data already and I've come up with this model. P equal to 14.7 plus 0.47 D. Also, I'm now thinking that that was supposed to be 5. Do, 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 do. Is this is supposed to be a 5? So 0.45. So another way that this question could be asked is, what is big P when D is 3,000? Sorry, you don't need the units right there. How can I figure that out? Yes.
So on the test, can you use a calculator for this stuff?
These the numbers aren't going to be, I haven't thought about calculators too far. In my syllabus, I said no calculators on exams. So the problems are going to be that you'll be able to like easily calculate. Nothing like, I'm not going to give you a number like this, right? This is just for practice and like real world sake. So the numbers need to be a little bit more believable. So how can I figure out what P is when D is 3,000? And I have this equation for P. Yeah, I can just plug in, right? So I can write that P is equal to 14.7 plus 0.45 times 3,000. Right? And once I'm done plugging that into my calculator, I should get 1,364 and 7/10. But this answer, I was given units. I would be given pressure earlier, was given to me with pounds, pounds per inch squared. This question didn't have all the information to tell you that what pressure was, but it was related to the problem earlier. So I just plugged in 3,000, right? I only have one thing I can plug it into. I'm trying to find what P is, so I just plug in to D and I'm good. All right? Are we feeling sideways, down, up? Okay, cool. And that ends 1.3. Great. Moving on. Let me find 1.4. Oh, it's asking me to rate it. Okay, great, cool. So now we're going to talk about, let's zoom in. Section 1.4 is going into depth about kind of more. So the model, like last section, we kind of just talked about how we can create a model. Now we're kind of diving in to the more theory of it, of like what it means to be a model and the concept of a function, which we kind of touched a little bit, right? So before we define a function, we're going to define what it means to be a relation. So a relation is a rule that sends a value to another value. So say you work at Disney World. You're one of the people that you're a cast member. I'm your manager. You come to me every day and like, you are Snow White today, go. You are Prince Charming, go. And I'm the relation, right? I'm the rule that says, you come to me, I send you somewhere. Go work at Magic Kingdom, something like that, right? What if I tell you to go be Cinderella and Prince Charming? That's going to be a little hard to do, two things at once, right? A function is a relation which each input gives exactly one output, right? To do my job right, I want to be a function. I can only send one person to do one job. I can't tell you to go be in charge of something while doing something else. So not every relation is a function. A function is a specific type of relation. Okay? So we usually like to draw them with these little inputs and outputs. So we're asked to identify which is a function. So my inputs are 1, 2, 3, and 4. 1, 2, 3, and 4. Right? And then my cursor's in the way. My outputs are 10, 20, 30, and 40. These lines are kind of saying I'm sending 1 over to 10. We also call this a mapping. I'm mapping 1 over to 10. I'm mapping 2 to 20, 3 to 30, and 4 to 40. Is this a function? And why? You ran out of answers today. Bethany says yes, it is a function. Bethany, why is it a function? Every input has its unique output. Right? So I'm only ever sending one input to one output. All right? So now we go look down at B. Now 1 is still going to 10, 3 is now going to 40, 4 is now going over to 50, but 2 is going to 20 and to 30. So is this a function? No, right? What was the, okay, yeah. So this one is not a function. Two is sent to 20 and 30. Right? 2 is double timing 20. It's cheating on 20 with 30. It's cheating on 30 with 20. Not cool. No cheating. So that's how I was, someone explained it to me. That like these inputs, everyone has to be, these inputs need to be loyal. Outputs currently do not need to be loyal. That's not cool. But these inputs, they need to be loyal. This one is not, so therefore it's not a function. Okay? Does everyone feel comfortable with that? Thumbs up, thumbs sideways. Okay, great. Cool. So that was kind of a picture, but now let's look at a table. There's nothing wrong with something not being a function, right? That's no shame on them. Some data just, it doesn't make sense for it to be a function, right? So these are some tables from your textbook. So below are 2 tables, and we're going to identify, again, which one is a function, or which ones are functions and which ones are not. So we're given the year, and we're given the number of women in the Senate, right? In 1997, there's 9. In 1999, there's also 9. And then we see in 2001 and 2003 and 2005, there's still 14. So I have multiple inputs with the same output. Is it still a function? Raise your hand if you think it's a function. Raise your hand if you're still thinking about if it's a function. Because your hand didn't show up, I'm about to call on you. Okay. Does anyone think this is not a function? Okay. Carter, do you want to tell me why you think it's not a function? That's a totally, like, I just want to know.
I just thought it wasn't because what you said about
The cheating?
but now I realize that's not the same number.
Yeah, exactly, right? So that's kind of, there are functions where one output only has one input. Well, those are a special type of function. Ah. But yeah, I wanna, if I tell you, if like, right, I input it into something, I don't want to get 500 answers out. That's confusing. I want one answer. Even though the answer for 2 different questions can be the same, I still just want one answer, so one output. So this is a function. It'd also be weird if the number of people in the Senate changed in a 1 year. All right. So our next table is the age of women versus the number of children that they have. So just they took a sample of women and their ages and how many children they have, right? So these aren't technically in any order, right? So I have one woman that's 31, she has 3. Another woman that's 24 and she has 1. And so on. So looking at this data in this table, can I model this with a function? No, right? Who's the problem number? 31, right? 31 goes to 3 and 31 goes to 2. Right? It doesn't make sense that everyone's 31 years old and then they have exactly 3 kids. That's stressful. I don't want that. So this is not a function. All right. So, guys, we're making great on time. Coolio. So, when we say that y is a function of x, we say it like, it kind of means like if each value of x or input corresponds to exactly one value of y, output. So in that case, x is what we call the independent, wait, hold on. Independent variable. Ooh, what did I fail? Doodle-doo-doo. Ooh. I got a raise. That was my email. Okay, and y is what we call the dependent variable. Right? So x independent, something that I can't really ever change. Time is a really popular independent variable. I can't control time. It's gonna keep going. And then something might depend on time. How far away am I in my compute? That depends on how long I've been driving. It's another example. Mathis, do you have a question or are you fixing your math? Oh, that's okay. I'm wearing hoop earrings today and I had headphones on listening to my class earlier today, and I like literally could not. I was like strangled. They got all messed up. So not gonna wear these for a while. Okay, cool. So is everyone okay with independent variable versus dependent variable? Right, it kind of in the name gives a little hint of what we're talking about. Y depends on X. I get Y from picking X, okay? So how can I tell by looking at an equation if it represents a function? Well, an equation gives sets of ordered pairs, right? X and Y, right? So for example, Y equals X squared, give me some ordered pairs. If I plugged in 0, 0 is a point, 1, 1's a point, -1, 1 is a point, and 2, 4 is a point, and so on and so forth, right? I could take these ordered pairs and put them into something that looks like this, called a tabular model, a table. And I could do kind of the same thing, right? So an equation is a function if the corresponding ordered pairs is a function, right? So if I looked at all these ordered pairs, there's infinite amount of them, and made them look like something like this table, as long as I have no 2 inputs that if I have the same input giving me 2 outputs, I'm a function. Does that make sense? So if my ordered pairs kind of follow that same rule. Any questions? Okay, great. So if I give you an equation, it's kind of like I can't test every number to see if something's a function. You don't have all the time in the world to do that, right? So if I give you 5z plus 2w squared equals 8, and I ask, is z a function of w? The way to solve this is it's going to actually help a lot. if I can write the equation as z equal to something, right? That'll help me figure out if it's a function or not, to see if I can get two, or if I'm getting multiple answers out or just one, right? So I want to write 5z plus 2w squared equal to 8. I want to solve for z, so I want z equals, right? Because we said earlier, is y a function of x? So think of z right now as like our y. We want z equals. So how can I rewrite this equation to be z equals? Yes. Yeah. Yeah, so right, we're gonna subtract 2w squared onto both sides, and then I'm gonna divide by 5. Z equals 8 minus 2w squared over 5. So for each w, so for each input, z is defined to be eight minus 2w squared over 5. If I plug in any w, how many values am I going to get out when I plug it in here? I'm only going to get one answer out, right? Even though there's a squared, that just means I multiply w by itself again, right? So I'm only getting out one value. So z is a function of w. I write function fxn. That's just a quickhand. That's what that is, by the way. Okay, cool. So now if I ask you w is a function of z, we should probably get our equation to be w equal now, right? So how can I write 5z plus 2w squared equal to 8 as a w equals equation? What can I do first? I would subtract 5z from both sides. Good job. Then what can I do? I would divide by 2. So I get w squared 8 minus 5z over 2. But I don't have w equals, I have w squared. Right? So that's going to equal w equal to plus or minus, good job, the square root of 8 minus 5z over 2. So for each z, w, whoopsies, has 2 values. If I plug in 0, I get 8 divided by 2, 4, but I get plus or minus the square root, right? So I have two values for each input because of that plus or minus. So we conclude that w is not a function of z. Yes.
Do you assume that with people that have it's like squared, or are there other instances where it's not?
So you can make, it's kind of what we talked about, I forget what chapter it was, but if I take an even root, so the 4th root, 6th root, I get plus or minus, right? But what if I take the cube root? What if it was like W cubed? Right? So you can make that generalization, but I want you to be careful about what that generalization is, right? So if this was, if I'm taking the cube root, I don't need plus or minus for the cube root, right? I only need it plus or minus for if it's an even root. So yes and no. All right, cool. What time is it? We have like 5 more minutes. Okay. We're gonna finish up the last thing on Thursday, but that's fine because that's why I made your exam next Thursday. Okay, cool. So we have a new definition. The textbook brings it up a little earlier if you ever read the textbook. I like to bring it up now. So we call the net change, whoopsies. So the net change in Y between inputs A and B is the difference between the outputs A and B. So what's the difference of when I started my commute to halfway there? It's probably gonna be like 10 miles. I don't live that far away, but something like that, right? And we're gonna work through an example in a hot second. So when the wind blows with speed V, our speed is gonna be in kilometers per hour. A windmill generates big P watts of power. According to the equation, P equals to 15.6 V cubed, right? So we're first asked to, we're first asked to show that P is a function of V. So the question is like, how do I show that? Like, I can't just show that everyone is. How do I show that P is a function of V? What is something I can kind of like say? I already have P equals 2, right? I don't need to move the equation around. Every time I put in a V, I'm not going to get, I don't have any like plus or minus. So I'm only going to get one output for every input. So I can just say each value of V has a unique P. All right, I just put in one value of V and I get one answer out. When we get 2 is usually when we have plus or minus, right? That's if I have plus and minus involved in an equation, that's going to be a really good indicator that I'm not a function. Okay? Let's do this last one and then we can do our exit, slip, and skedoodle out of here. I love that word, skedoodle. Okay, cool. So if I want to find the net change in power, P, as the wind speed changes from 7 to 10, remember net change is the difference between the outputs of A and the output of B. So the output, so V is 7. What is P going to be? What's my output of 7? How do I figure out what P is? So V is 7. So P is going to be 15.6. I'm going to plug 7 in, and I'm going to cube it. So then plug that into my handy dandy calculator, and I get what? 5,350.8. What's the unit of power? Watts. Pretty sure that's just a W, right? Ooh. I just plug it in to the equation since I'm already given P equals. So then for V equals 10, I do the same thing. This one's a little easier to plug in. I get 15,600 watts. So those are the outputs for 7 and 10. How do I find the net change between them? Subtract. Who do I subtract from who? You're right, Bria, that we do subtract. Do I subtract like 15, the 15,000 one from the 5 or vice versa? So, you mean like something like this? Minus 5, 3, 5, 0. Right, yeah, we want to do the second one minus the first one. Net change. Just because, right, we're going 10 to 7 to 10. Your net change might be negative, but like we're not, how can I explain this? And then when you do your extra something, you guys can go. You want to do the second one minus the first one. So you get an accurate net change, right? You can see at when my speed is 7, that's how much power I'm getting versus 10. Yes.
Didn't you also think of it like the real world that like the winds?
That as well. Well, not the wind speed, the watts. You can think of someone using watts as watts going away. But yeah, technically, right? So once I subtract these two, I get 10,249.2 watts. And we'll review this again at the beginning of next class. I just ran over time. Oh no. So we'll talk about this more next time, but think about why we want to do 15,600 minus 5,350.8. Exit slip time. Best time of class. Hi, Paige. All right. So remember that our room is black. 943, right? That's capital K. No spaces. Our teacher question of the day is going to be, is y equal to x squared? Wait, no. So if y equals x cubed, is x a function of y? Yes or no? Is x a function of y? And then you can always skedaddle after that. So that kept you a little too long. Don't forget that these notes are always posted before class. If you ever don't want to write a lot of things down, you can always print them out. Hi.
Question about the web assign, it like
Yes.
asks for what the quadratic equation is, and for like the plus minus, like I don't know how to type this, and then I couldn't get it right, and then
It's okay. It's still one of your problems this week, right?
yeah,
I
it's
think,
the first question on the web assign. I just couldn't.
yeah, I wanted you guys to get practice with putting plus or minus. I think it gives you a chance to do one with plus, comma, one with another one.
Oh, that's what it. Okay, it said something about common, then I didn't know. What
Ooh,
it
yeah,
was.
that's
Okay.
what it was. Yeah. So when you have a plus or minus, that's not a symbol that it recognizes.
Yeah.
So you do like
Just
the
do
equation
one
with
separate and
plus,
separate.
comma, and then you can like literally just copy and paste and put it
Okay,
with
that makes
negative.
sense. Thank
Hi,
you.
friend.
Hey, so I didn't even realize until you mentioned in class about the comments, and when I looked at the homework, I noticed that I did the wrong one.
Did you do the optional ones?
I think I did the optional
Okay,
one
let me stop
instead of-
recording. Just because the internet doesn't need